And good morning, fourth grade math masters. Welcome to another exciting edition of Mr. Leggett's Eureka Math. And what does Eureka mean? It's a Latin phrase. When translated into English, it simply means I have found it. And what have we found? Well, we have found the best way to learn new math concepts, such as fractions. And that, ladies and gentlemen, boys and girls, damas y caballeros, is more valuable than gold itself. All right, let's get started on our objective. It's to decompose fractions as a sum or total of unit fractions using los tape diagrams. Okay, first thing, our fluency practice, we're going to read some tape diagrams. Reading in math? Yes, it's true. First tape diagram we're going to create together is this fella right here. And he's a mighty fine looking tape diagram. And this tape diagram is going to be broken into three pieces. And let's say that this tape diagram equals the number 15. So this tape diagram is saying to me, Mr. Leggett, I represent 15, right, divided by 1, 2, 3. So I know that's going to equal something. And I also know, because division is the opposite of multiplication, that 3 times a mystery number would equal 15. So what do these little boxes represent within the tape diagram? Well, let's think about it. 3 times a number equals 15. 3 times what? Could it be 3 times 4? 4, 8, 12. No, maybe 3 times 5. 5, 10, 15. Oh, that seems to work. So we could say that 15 divided by 3 would equal 5. So each one of these little segments would be 5, 5, and 5. And there it is, ladies and gentlemen. One of those beautiful tape diagrams I've ever seen. Let's continue on with another one. Are you ready? Yes, we're ready to rock. Okay, we're going to take this here tape diagram. And this little fella, we're going to take him and make a tape diagram. We're going to break it into 4 pieces. Just 4. 1, 2, 3, and 4. And there it is. And this tape diagram is going to represent 8 divided by 2. And I know, you say, Mr. Leggett, I know that off the top of my head. But I want to break it all down. All right? So what we have going on, is the total is 8. The whole. We're dividing it by 2. Well, let's do an opposite of division. 2 times a number equals 8. What could it be? Could it be 2 times 3? 3, 6. I mean, excuse me. Could it be 2 times or something? 4 times something? What do you all think about that? 8 divided by 2. 2, 4, 6, 8. I think it's going to be 4, don't you think so? Or 2 times 4 would equal 8. So 2, 4, 6, 8. Who do we appreciate? Hope you appreciate me, boys and girls. I hope you do. Okay, we're going to continue on with another one. And this time around, we're going to take a tape diagram. There he is, looking brighter and better than ever before. Brand fresh new tape diagram. And we're going to divide them up, say the whole is 20 and we're dividing it by 5, okay? So there's our problem. Let's make the whole represent 20. A 20 right there. So now we're taking 20 and we're dividing it by 5. Let's cut that bad boy up into 5 pieces. 1, 2, 3, 4, and 5. So now I'm going to take a look at the opposite of division, which is multiplication. We're opposites. And I'm going to say 5 times a number does indeed equal 20. What in the world can this number be? Well, let's think about it. What about 5 times 3, 3, 6, 9, 12, 15. That ain't going to get me there. What about, we'll try 4, 4, 8, 12, 16. Oh, it looks like it's going to be 4. See? 4, 8, 12, 16, 20. 5 times 4 equals 20. 20 divided by 5 equals 4. There we have it. Let's continue on down here. And let's do another tape diagram. This one is going to represent a problem that's 12 divided by 2. It's going to equal something. All right, so let's go over here. make this represent 12, a dozen, and then we'll say, 2 times a number equals 12. What number could that be to solve this division and multiplication problem? Well, let's take a look. 2 times what equals 12? Could we do 2 times 5? 2, 4, 6, 8, 10? No. Maybe 2 times 6. 2, 4, 6, 8, 10, 12. Yes. So I'll break this into 6 pieces. 1, 2, 3, 4, 5, and 6. So I know that 12 divided by 2, 2, 4, 6, 8, 10, 12 is equals 6, right? 1, 2, 3, 4, 5, 6 spaces. So I can say 2 times 6 equals 12. And if you want, you can go 2, 4, 6, 8, 10, and 12. But you don't have to. All right. Let's see if we can squeeze one more in. Why not? Why not? Here comes tape diagram number 5. Welcome, tape diagram number 5. And this one is going to represent a pretty simple equation here. 8 divided by 4 equals something. So 4 times a number will indeed equal 8. That's how we're setting this up. 4 times what equals 8? Well, we can count by 4s. We remember how to do that, right? But before we do that, and I'm going a little too fast. I'm sorry, I'm a little too much coffee today. So let's take a look. Let's count by 4s. 4, 8. Oh, 4, 8. Oh, 4 times 2 equals 8. Right? 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 divided by 4 equals 1 space, 2 space. It equals 2. And there we have it. Now what I'd like you to do is to take your paper and you're going to turn it over. I can't use the back of my paper because there's ink all over it. So I have to grab another piece of paper. All right. I'm grabbing another piece of paper with, I hope, the application problem on it. And here it is. It's a big old long application problem. Let's see if we can do it in the time allotted. Are we ready? Here we go. Here we go! Miss Salcido cut a small birthday cake into 6 equal pieces for 6 children. Well, let's first of all circle the numbers. 6 and 6. Let's underline what we know. We know that Mrs. Salcido, she cut a small birthday cake into 6 equal pieces for 6 children. She got a small birthday cake because she didn't care much for the kid. I'm just kidding. Let's continue on. One child was not hungry. Oh, he ate before he got to the party, no doubt. Yes, Mrs. Yvonne, Princess Yvonne, he did that. So we'll say, one child was not hungry, so she gave the birthday boy the extra piece. Well, that was very nice. I would have put it in a plastic baggie and brought it home. But she said, you know what? I'm full. You can have a birthday boy. So what we need to do is draw a tape diagram to show how much cake each of the 5 children received. All right, let's continue on. Let's figure out. First thing, we're going to make a tape diagram. And this here tape diagram represents the cake. How many pieces do we cut the cake into? 6. 1, 2, 3, 4, 5, 6. So this cake, or this tape diagram represents the cake cut into 6 pieces. Now, we gave 1 piece to child 1. And I'm not going to write child 1, I'm just going to put C1. We got a 2, another piece, went to child 2. We go and give another piece to child 3. And yet another piece to child 4. But remember, when we got to child 5, she said, no thank you, I'm a fool. Give it to the birthday boy. So birthday boy gets 2 pieces of his little cake. Oops, I'm going to put 2 there. I'm going to put BB for the birthday boy. Well, let's decompose this tape diagram, color in that, to show what's what. All right, let's scroll up here. And here comes our tape diagram. It's 6, 6, right? We serve the entire cake, all 6 pieces. So 6, 6, 6 out of 6. We gave 1 to child 1. How much did child 1 get of that whole cake? He got 1/6. How much did child 2 get? If you said 1/6 to yourself, you're right. How much did child 3 get? You got it again. 1/6. Child 4, 1/6. And last but not least, the birthday boy. What did he get? He got 2 pieces, right? So he gets 2/6 of the cake. And there we have that. So now let's make this into a math sentence to decompose the 6, 6. Here we go. I'm going to say 6, 6 equals 1/6 plus 1/6 plus 1/6 plus 1/6 plus 2/6. And there we have it. So now we could say, we can answer the question. Well, actually, it wasn't really a question. It's just to draw a tape diagram to show how much cake each of the 5 children received. So I don't even have to write that sentence if I follow instructions, and that's exactly what I am going to do. I'm going to follow the instructions and leave it like this. Boy, we did that quickly. Me oh my. Now what you're going to do is you're going to flip over your paper, because we're heading to concept development country. It's a wonderful country. You should visit it sometime. Well, in fact, you're visiting it today. It's time for the concept development cruise, I guess we could say. And we're going to try to do this in an incredible, let's try to do it in 20 minutes, even though the recommended time is 34. It says, use a number bond, this is what we got to do, to show how 1 can be decomposed into fourths and how fourths can be composed to make 1. So I'm going to circle 1, and I'm going to circle fourths, and then I'll circle fourths, and I'll circle 1. How do you like that? Let's figure this out. Okay, 1 is the whole, and we're going to decompose it into fourths, okay? And the 4 1/4 are parts, so 4 fourths make 1, right? But let's do a different addition sentence with this, okay? Let's say that 1, we're going to do a couple of different ones here. 1 equals, and write this down please, 1/4 plus 1/4 plus 1/4 plus 1/4, right? We get 4 fourths there, right? 1, 2, 3, 4. Remember, we don't add the bottom number. I'm not going to tell you what that's called till later on in the video. We'll review some math terms. So 1, 2, 3, 4 fourths equals 1. All right? So let's go ahead, and what we're going to do, let's create a different number sentence, okay, to see what's what. Let's create a different number sentence to decompose the 1. All right, I'll say that 1 equals 1/4 plus 1/4 plus, and I only want to do one more fraction. What fraction should that be? 1 plus 1 is 2. Well, then we would just put 2 fourths. Right? Would that equal 1? Sure. 1, 2, 3, 4. 4 fourths. And we're going to make a number bond showing this. Decomposition. There's our 1. And we'll put 1/4. 1/4. And what's the last one going to be? You got it. 2 fourths. How else could we do this? How else could we decompose that 1? Well, I'm thinking we could do some other things. Can we add these two together to make 2 fourths? Let's give that a try and see if it works. So we can say 1 equals 2 fourths plus 2 fourths. Does that work? You bet it does, because this equals what? 2 plus 2 is 4. And remember, we don't change the bottom number. It's going to remain a 4. So we have 4 fourths right there. Let's decompose it. I'm going to say a 1 here, my 1 whole. Hi, I'm a 1 whole. And we're going to just decompose it 2 fourths and 2 fourths. 2 fourths and 2 fourths. And there we have it. And let's do one more. Let's think about how else we can decompose 1 into some fractions. Well, I'm thinking we could take 1 and it equals, can we go 3 fourths plus what? Yeah, plus 1/4. What would that equal? That would equal 4 fourths. And what do 4 fourths equal? Well, they equal 1. And there we have it. So if I was going to do a number bond, of this, I would just have to go 1, and you guys might not be able to see this fading pen. Let me try to get a better one. We would just have 3 fourths and 1/4. That's how we decompose this all into different kinds of fourths. Isn't it nice? Now, for the next segment, let's go to problem 2. And it says, it's time to fold and no one's around to help you. You're going to be on your own. Fold a piece of paper to create 8s. And then it says decompose fractions in different ways, all right? So you're gonna take your strip of paper, and Mr. Lincoln's gonna grab his strip of paper, excuse me, and go from there. I'm grabbing my strip of paper. Yours will be much straighter than mine, I hope. And we're going to fold it into eighths. Eighths. It's a hard word to say. So you have your paper here. Fold it once in half, right? And all you have to do is fold it in half again. How many do we have now? Let's see. Oh, we only have 4. 4 times 2 is 8, so let's fold it again. Let's see how that works. Will I have 8? It's a mystery. So we have 1, 2, 3, 4, 5, 6, 7, 8. So what we did is we folded it in half once, fold it in half twice, fold it in half 3 times, and voila. There you have it. 8 different pieces, or segments, not pieces. So we're going to take a look at this fascinating piece of paper, excuse me. I'm going to zoom out a little bit. Let's go ahead and mark it off along the creases. 1, 2, 3, 4, 5, 6, 7, and 8. And there we have it. All right. So let's shade in 7 of our 8 parts, okay? 1, and remember we don't have to go crazy, make it all nice and neat. 2, 3, 4, 5, 6, and 7. So of course, what fraction does this represent? 7 out of 8, 7 eighths, 7 of 8, and so on. So how can we decompose this? Let's think about, we're going to use parentheses too. Oh, I said parentheses. Look who's coming out to talk about parentheses. None other than our good old friend, the Math Mutt. Math Mutt, I see you running in the distance. Yes, Mr. Leggett. I heard you say parentheses, so I decided to come and see what was going on. Well, what's going on is we're using parentheses to decompose the number 1 into fractions. Oh, I like the fractions too. The fractions are a lot of fun. And parentheses and fractions together, well, my goodness, I can't think of anything more fun than that. Well, Math Mutt, what do we do when we see a parentheses in a math problem? We do the parentheses first. We always do the parentheses first. Parentheses go first. Yes, they do. Thank you for reminding us that so much. You really like parentheses. Yes, I do. Do you have any plans for the night? I am going to go to the store with you to buy cat litter for the calculating cat. Oh yeah, we got to do that. That won't be too much fun, but we can make it fun because we can talk about parentheses. Okay, we'll do that. Parentheses, they always come first. Arr, arr. Thank you so much, Math Mutt. You're always a welcome addition to our math lesson. All right, so there we have 7 eighths. Let's think about how we're going to decompose this using parentheses. And here we go. Let's write 7 eighths. It's not a whole, right? It's 7 eighths. And let's think about how we could do this. Think about like what plus what equals 7. First thing that comes to mind is, I don't know, 3 times 4. So let's take our 3 eighths for here, and we're going to add them together. We're going to go 1 eighth plus 1 eighth plus 1 eighth. That's a terrible looking one. So we have 3 eighths, right? And we'll put these in the parentheses. And what will we need to add to this? Well, we need to add, how many do we have left? We have 1, 2, 3, 4. We could go like this. Couldn't we go 2 eighths plus 2 eighths to show 4? So we'd have 2, 4, 5, 6, 7, and we'd have 7 eighths. Let's figure this out. So 7 eighths equals, we'll do the parentheses first from left to right, 1, 2, 3 eighths plus 4 eighths, right? 4 plus 3 is 7. Lower number remains the same. I'm going to set up another one, and I'd like you to finish it on your own and then check back. Let's say 7 eighths equals blank eighths plus blank eighths plus blank eighths plus blank eighths. So what I'd like you to do is figure out what the top number, and we're going to talk about those phrases, the proper math terms for the upper and lower numbers later on today or this week. We're going to have a special guest come in and help us out with that. So let's think about how we could do that. Have any ideas? We know that this top row has to equal 7, right? So think about what we could add to equal 7. If you're stuck, maybe you want to put a 3. There's a couple of different variations of this. 3, maybe? Plus 1. So what's 3/8 plus 1/8? That would equal 4/8. And what can we put over here? Well, I'm still 3 away from 7. What equals 3? Couldn't we just go 1/8 plus 2/8? Yeah, we could. So it'd be 4/8 plus 3/8 does indeed equal 7/8. All right? And we're going to continue on with problem 3 in our concept development. And that's write number sentences to decompose 5/6 as a sum of fractions with the same denominator. There is that number. It's the number on the bottom of the fraction. We're going to call that a denominator. Say it with me to yourself. Denominator. So let's circle 5/6 as a sum of fractions with the same denominator, the number on the bottom. Remember, we don't add those, okay? So let's go ahead and get started on that. And we'll say, let's start with 5/6. That's what we're working with. And we're just going to decompose it using 1/6, okay? 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. We have 1, 2, 3, 4, 5, 6, okay? So how else can we decompose this? Let's say 5/6. Could we go like this? Let's think about it. Couldn't I go 3, 6 plus something else? What would that be? Well, 3 plus 2 is 5, so it could be 3, 6 plus 2, 6, right? And we could do this a couple other ways. I know your wheels are turning, as they say. We could say 5/6 equals, couldn't we say 4/6 plus what? Well, 1/6, correct? There's all sorts of ways we can do this. Let's keep going down, and we'll say 5/6 equals, can we do 1/6 plus 1/6 plus 1/6? And then what else do we need to do? Well, 1, 2, 3, we got to get to 5, so we could go 4 and 5, 6 using that 2. All right? So let's see how else we can do this and show it. What you're going to do is you're going to turn the paper over. It's blank. Mine isn't. But yours will be, because you've been using pencils. So let's just take a look at how we can do this. And I don't think I want to go on with this 5/6. We've done that enough. Let's shift gears a little bit more and get a little trickier. Let's do 5/4. Now remember, the top number, which we call a numerator, and we're going to be hearing a numerator and denominator a lot in the upcoming weeks. Let's go ahead and break this down, decompose it to 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. 1, 2, 3, 4, 5/4. Okay? Remember, when the numerator is greater than the denominator, this fraction is greater than what? If you said to yourself greater than 1, you are absolutely correct. It is greater than 1. So let's make the tape diagram. And this got kind of confusing, and I don't blame you. And let's make 5 segments. 1, 2, 3, 4, and 5. Well, what is each unit? It's not 1/5, right? Because it's 5/4. So this is 1/4 right here. And let's make 1/4 again. So that's what it looks like. We have 5/4, don't we? 1, 2, 3, 4, 5/4. So where's number 1 going to end at? Well, if you think about it, 4/4 is right there, so we have 1 extra. So this would equal 1 whole, but we have greater than 1. And watch how this works here. I hope this will help you understand this. Let's do our 1 first. There's 1, 4/4. But what we have going on is more than 1. So we put in another 4th. And we're on our way to 2 actually. So there's the 1 and there's the other 4th. So 5/4 is just 1/4, 1/4, 1/4, 1/4, and 1/4. It's greater than 1, but no but necessary. I don't know why I said that. So let's just do this one other way, because we're running low on time, I see. And we're going to take I'm going to take my green, you're going to take your pencil. We're going to show this just another way. Make your tape diagram. And we're going to break it into 5 pieces, right? 1, 2, 3, because we're dealing with 5/4. And we're going to show the number 1 again. It ends right there. Remember, it's 5/4, so there's my 1. And let's see what we get. 1/4, 2/4, 3/4, 4/4. So we have 4/4. What do we have left over? We have 1/4 to make 5/4. And watch the beauty of this. This is going to be 1/4. So how could we write this as what we call a mixed number? That's going to be another phrase you're going to be hearing a lot. Well, think about this. 4/4 is 1, right? So I would say 1 plus 1/4. And what would that equal? Look at this. Think about it. It would equal 1 and what? This is the time in math when we could use and. 1 and 1/4. And there you have it, ladies and gentlemen, boys and girls, damas y caballeros. You can go and take a pause on your video if you'd like and stand up and stretch a little bit. And when you get back, you'll be working on the problem set. And that is page 119. And today's date is the 27th, 2020. All right. So I'm going to zoom in a little bit. Whoops, I'm going to zoom in a lot, I guess. All right. Sorry, everyone. Okay, here we go. Hope you had a nice stretch break. Step 1, we're going to draw and shade a tape diagram of the given fraction. We're going to record the decomposition as a sum of unit fractions. We're going to record the decomposition of the fraction 2 more ways, and the first one has been done for you. Thank you, fine folks of Eureka Math, for doing that. We appreciate it. We think you're the bomb. So let's get started on our first problem. We'll just kind of review it. What they had here was 5/8. So they made a tape diagram, right? They shaded 5. They showed that it's 1. Then they did 5/8 equals 1/8 plus 1/8 plus 1/8 plus 1/8. Then they decomposed it another way. 5/8 equals 2/8 plus 2/8 plus 1/8. And then they decomposed it a third way. 5/8 equals 2/8 plus 1/8 plus 1/8 plus 1/8. Let's get started on this. I can't wait. I'm telling you, I cannot wait to get started on this. It looks like it's going to be a real challenge, and I'm always up for a challenge. Yes, I am. Go, goodness me. Get in the paper, Mr. Leggett. All right, there we go. So our first one is 9/10, okay? So let's make a tape diagram of 9/10. I'm making it extra long so we can see. Say, what does this represent? Well, it's less than 1 because the numerator is smaller than the denominator. So we're going to show a tape diagram with a bracket of 1. Hi, 1. Well, hi, Mr. Leggett. Now we're going to break it into how many pieces? Well, we're going to break it into 10 pieces because there's 10 pieces in this one. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many will we shade in? Well, it's 9/10, everybody. So we're going to shade in 9 of these. And I'm just going to go 2, 3, 4, 5, 6, 7, 8, 9. Thank you, Princess Yvonne, for helping us out on that one. You're welcome. And so we'll go over here and we'll say, okay, let's break it down in the ones way. That's a lot of ones. I think we could do better than that. Let's go 9/10. Remember, we're trying to get to 9, okay? We're trying to get to 9 over here. All right, oh, here we go. So 9/10 equals, I'm not going to go 1/10, 1/10, 1/10. Let's do 3/10. Do you see where I'm going with this? 3/10 plus, I bet I can do the same number. 3/10 plus what? 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 3/10. There we have it. Let's do it another way. 9/10 equals, what else equals 9? When I roll a dice, 5 and 4 equals 9. So I can do 5/10 plus 4/10. And let's do another one. 9/10 equals, what about 7? What if I did 7/10? What would I have to add on to get to 9/10? Well, 7, 8, 9. So it's 2/10. 2/10. I like saying that. Let's go to our second one. 3/2. When we say 2 is the denominator, we say halves. So there's 3/2. Think of it as 3/2 of a pie. You got one whole pie and then a half. So I'm going to make a big old tape diagram so you really hopefully understand this all nice and neatly. And okay, I have 3 pieces, right? 1, 2, and 3. Where's my 1 going to go? Well, if I have 2 halves is a whole, right? As far as where I come from, 2 halves are a whole. So I know my 1 is going to be right here. Think of that as half a pie and another half of a pie, or half a pizza and half a pizza, and then you got another half left over. So how are we going to break this down? Well, let's get to it. We're going to shade them all first, 1, 2, and 3, and then we'll say 3/2 equals 1/2, right? Plus 1/2 plus 1/2. What's another way we could do this? We could say that 3/2 equals, what if I did 2 halves are 1 whole? What would I need to add on? Oh, just another half. And I think we've kind of exhausted our possibilities. I could switch them around and do other things, but let's just stop right there and turn this paper over. Alrighty, what they're asking us to do here is step 1. Draw and shade a tape diagram of the given fraction. Record the decomposition of the fraction in 3 different ways using number sentences. Oh boy, we're using some more number sentences. Huh. Here we go. We're going to start off with 7/8. One, 2, 3, 4, 5, 6, 7, 8. How many are we going to shade in? Well, if you said 7, you're absolutely right, because it's 7/8. So we have 7 out of 8. We have our 1. And, and they want us to do the unit fractions of 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 equals 7/8. I think we got that. So let's do 7/8. What 2 numbers equal 7? What could we use? We could use 4 plus what? 3, yeah. And let's do another one. 7/8 equals how many 8s plus how many 8s? Remember, we have to get to that number 7. Well, think about different combinations of 7. What if I were to put a 5 here? What would the numerator of that one be? The top number, the numerator. Well, if you said 2, you're absolutely right. B is one of those, what we call an improper fraction. We're going to talk more about that. It's 5/3. So let's make a tape diagram. How many thirds are there? There's 5. So we got to go 1, 2, 3, 4, and 5. Where will my 1 be? Well, remember, 3/3 would equal 1, so 1, 2, 3 is my 1. So this is greater than 1. When the numerator, the top number, is greater than the denominator, it's greater than 1. I'm shading all 5. The numerator, we shade all 5 because the numerator is 5. Now, how could we equal and decompose in a number sentence? We have 5/3. Now remember, equals. This is going to be a third, and this is going to be a third. What numbers are going to be on top? Well, those two numbers got to equal 5. When I think of numbers equaling 5, the first one that comes to mind is 2/3 plus what? 2, 3, 4, 5. 5/3. Let's do another one. 5/3 equals a number, our fraction plus a fraction, and their thirds. What else could we do? Could I do maybe 4/3? What do I need to get to 5/3? Well, I know I need to get one more, and that's 1/3. Okay, time to get to 7/5, another improper fraction. We're going to break this into 7 pieces. The numerator, 1, 2, 3, 4, 5, 6, and 7. We're going to shade all 7. And we're going to show our 1. Well, our 1 would be at the 5th, right? 1, 2, 3, 4, 5. There's our number 1. Now, we have 7/5. How are we going to decompose this using a number sentence? 7/5 equals what? So this 5th plus this 5th is going to have to equal 7/5. We could do 5/5. How many more do we need to get? 5, 6, 7. Plus 2 is 7/5. Let's do another one. 7/5 equals, what if I were to put 1/5 here? What would I need to add to get to 7/5? Well, if you said 6, you're absolutely correct. Okay? Our next one is a mixed number. It's 1 and 1/3. So we're talking about thirds. Okay, let's do this I'm going to get out my big pens. Let's make our 1 first. Our 1 needs to be made up of thirds, right? Because it's 1 and 1/3. So let's go 1, 2, and 3. There's my 1. 1/3, 2/3, 3/3, 1. Let's go with our extra third, because it's 1 and 1/3. And there's 1/3. So we have 1, 1/3, 2/3, 3/3, 1, plus 1/3 is 1 and 1/3. Remember how we did this in our concept development? We say 1 plus, I'm not going to switch, 1/3 equals 1 and 1/3. Well, let's see how we could now figure this out. 1, 2, 3, 4/3 equals 1 and 1/3. Ding, ding, ding. What a bold new concept we've learned today. 4/3 equals 1 and 1/3. And we could just do some pretty easy ones here, couldn't we? Could I just do 2 plus 2? 2 plus 2 is 4. And then let's do another one. 4/3 equals how many thirds plus how many thirds? It has to equal 4. What's another way to come to 4? Couldn't I do 3/3? The 1 plus 1/3? I can. So what I'd like you to do is thank you. I want to thank you first for being such a wonderful audience. You're going to take all your notes and you're going to take them home to help you with your homework, along with that strip of paper. Hopefully that will really help you out, okay? This has been another production of Mr. Leggett and Eureka Math. Whoa! We just made it. Yay!